So for number 16, we want to first eliminate the parameter to obtain an equation x and y, and then we want to describe the curve and indicate the positive orientation. So to eliminate the parameter, first we're going to isolate t in terms of x, and whatever expression we get for t in terms of x, we're then going to put it into the y equation so that we get rid of t. So we have the equation that x for 16, so x is equal to 4 minus 3t, and y is equal to minus 2 plus 6t. So we're going to take the first equation and isolate t. And so I'm going to do x minus 4, so I bring the 4 over to the left-hand side. And then I'm going to divide everything by minus 3 to isolate t. So divided by minus 3 is going to be equal to t. And once I have an expression for t, now I can, in terms of x, now I can plug that in here, because if I plug that in there, I'm going to get rid of t. So we have that y is going to be equal to minus 2 plus 6t, so plus 6, and we're going to plug in this expression for t, x minus 4 over minus 3. So let's just clean this up a little bit. We have that y is equal to minus 2, and then 6 divided by minus 3 is minus 2 times x minus 4, and that becomes y is equal to minus 2 times x, so minus 2x, and then over here we would have minus 2 times minus 4, so plus 8 minus 2 plus 6. So this y is equal to minus 2x plus 6, that is our actual equation, right? It's going to follow this line. However, because t has a restriction, t is bounded from -1 to 3. So because it has a restriction, it means that this line is not going to be infinite, right? Rather, it's going to be a line segment that has a starting point and it has an endpoint. So let's find where those endpoints are. So let me just erase this. I'm going to leave the equation when we eliminate the parameter. But now, if t is equal to minus 1, which is the starting point here, let's see what that would be in terms of x and y. So I'm going to plug minus 1 into the x equation. So x would be 4 minus 3 times minus 1, which therefore means that x would be equal to 4 plus 3, so 7. And then I'm going to plug in t is equal to minus 1 on the y equation. So that would give us y would be minus 2 plus 6 times minus 1. So minus 2 minus 6, y is equal to minus 8. So it begins at this point when t is minus 1, which is the beginning of our parametric curve. The point that we're actually at is the point 7 comma minus 8. So we're going to say begins at the point 7 comma minus 8. And now let's look at where it ends. So it ends where t is equal to 3. So similarly to what we've done, we're going to plug in 3 into these equations for x and y. So x is going to be equal to 4 minus 3 times 3. So that's going to be 4 minus 9, which is x is going to be equal to minus 5. And y is going to be equal to minus 2 plus 6 times 3, so minus 2 plus 18, so y is going to be equal to 16. So we can see that when t is equal to 3, which is the endpoint, right, of this line segment, it means that x is located at minus 5 and y is 16, and ends at I would say minus 5 comma 16. So we can see here, maybe I should say that this is a line segment, because this curve here is a line, right? But it has a starting point and an end point, which therefore makes it a line segment. So that's it for 16. We eliminated the parameter and we were able to indicate the positive direction by stating where it starts and where it ends.